Hello guys, hi everyone, hi all. Right now I'm starting my own YouTube channel. It's 5:02 in the morning, and I haven't slept much. So from now onwards, I will be teaching these algo every day. I will try to solve at least 2 to 4 problems every day. The DS algo. So let us just start with the first problem without wasting any more time. So this problem is called the Pascal's triangle. So what this means is, let us just let me just try to explain the problem itself. So here we are given an integer called numbers. Uh, this is the input. This is the input numbers, and we need to output this 2D array triangle. This is a 2D array itself. This is the triangle, and in simple terms, it's just a 2D array with the variable column length. Like the number of rows the same, but the number of columns varies for every row. Here, here we have the number of column as 1, the number of column as 2, number of column as 3, number of column as 4, column as 5. So here for every row we have different number of columns. So we can't just use arrays in it, because arrays in arrays we have to like initialize the let us just explain it. So sorry for all the disturbances and all those all disturbances and all, because I can't really do anything about it. So in array what we have is we first need to initialize the array with a size. Like here for 2D array we need to define like here we need to give the number of rows and the number of columns at the initialization step itself. Like here when we initialize the array, then only we need to give we need to pass the number of rows and the number of columns value. For that reason, that the array is a static data type because of that reason itself. And the other thing is, like here for every row there will be some different number of columns value, and the other reason is that because because here we have a triangle, we can't just we are not having any like we are just having a triangle. So yeah, so that and that is the same reason itself, because we have different number of columns value. Yeah, and okay, and the like the other con of that is like here we can't just resize any we can't just resize this size of any array, or maybe the number of rows, the number of columns of any 2D array. That's why we need to use some sorry that's why we need to use some dynamic array, and for that reason itself we will use vector. We can use array also, but for the array we need to use the dynamic memory allocation, which we see in C and C++. Like in C we have the dynamic memory allocation through malloc and calloc. Yeah, so and also we need to use more complex uh, pointers concept as well, because with that only we can use the array for solving this problem. But in vector we can easily do it, because vector is just a dynamic array. Because here in vector we don't need to define the size of the vector array at the initialization step. Like we can uh, skip that step of giving the size as giving the size of an array at the initialization step. So yeah, that's why we have to use vector. We have to use vector for getting this problem solved easily. For everything else, we need to use vector only, because in DSL going competitive programming, we mainly use vectors only because of its efficiency and the efficient nature. For going through the vector, you can use this link or GFG link, vector in C++ of standard template library. So vector is part of a the standard template library that is for the C++. Yeah. So here in the vector we already have all the things. We don't need to manually insert. Yeah, so we have many functions for the vectors. Like here, if you want to add any element at the back, we have to use this method for the vector array. So this method just inserts the element at the back of the vector array. You can also erase the last element. Yeah, so I will have a separate video for explaining all the vector things and all. For this, what the main thing is for this problem, for the outermost element of every row, like the first element of every row and the last element of every row is 1, as you can see, and the middle elements is just the sum of the previous row elements, where uh, like here we have these two elements whose sum is 2, and which we take in this uh, block. So this 2 is the sum of this 1 and 1, and for this one the row index will be that index minus 1, and the column index will be this index minus 1, because here we have the column index of this 2 as 1, and here we have the column index of this one as 0 only. And for this we have the column index as same as this, but the row index will be, of course, will be minus 1. So for both these blocks, the row index will be minus 1, but for the column we have only this as minus 1. So these two elements added will be getting in that block. So similarly, in a similar fashion, this loop goes on and on. So that's how the Pascal's triangle is built. 2 2 and 1 get added to form 3. The column index of 2 is the 3th column index minus 1, and this is the same column index. Yeah. So this is the formula that we can use. This is the formula. Okay, so for every block of ing of the index as ing, we have to use the row with index will be the I at minus 1 only for both the values that we are adding. The same only I minus 1, I minus 1, but for the first element we need to use g minus 1. G is the column index. For the first uh, element that we are adding, we need to use the column index as minus 1, but for the second element we need to use the column number as the same only as the same that we have here. Okay, so this is the main formula. We can call it as Pascal's triangle formula. Pascal, sorry for the handwriting, I don't have much experience in writing through mouse. Pascal's triangles formula. Let's leave it. Yeah. So That is how we can calculate the output. So here for every input, for every number of rows value given, we need to output the triangle, the whole triangle itself. For 5 we have this triangle, for 4 we have until this triangle, or till this. For 3 we have only this triangle until 1 to 1 only. For 1 we have only this block as a triangle. For 6 we can have one more row over here. So for every row, for every number of rows we can have the output as the whole triangle itself. So this output will be a 2D array, because this triangle is also 2D array, but here we will use vector 2D array. Okay, so that's how it's these are all the examples. So let us just now solve the problem itself. So this is the vector of a vector array. So as we have the 2D array, what is a 2D array? 2D array is an array of an array. Means we have a array data type, and for every element, every element of that array is itself an array. Is itself an array of integers. Okay, so that's how this is also right. This is the vector of integers, vector array of integers. Here we define the vector array as this, like here in C and C++ and Java we need to define, we have to define it by this int of I, a of int of a, where a is the array, and we need to define the size as 10. So int as the data type. So that's how we need to, that's how we define the vector array as this. Okay. So the generate is the method. Yeah, so these all things are given before as a prerequisite in Leetcode. Here we don't need to print anything, we just need to return this, the resultant value of this data type. This is the method that returns this data type. This is the data type of the resultant output. So here we just need to return a result. Result is the result. We will initialize it now. We will initialize it just now. Result is the resultant 2D array. Okay, 2D vector array. So here it returns this. This method returns this result, and will check, particularly it will check whether the output is correct or not. So let us just initialize it first. Vector. Let us just initialize the resultant vector, for which we will insert the values. Vector of int result. Here as it's a vector, so we don't need to define the size of, we don't need to write the size of this 2D array. But here, as we are given, as we know this number of rows value, as it's fixed only, so we can, so this vector is the number of rows, and for every row we have a column vector. For every element of this vector is a row, and for every row we have this vector, which is a column array. Okay, so if we need to define, if we want to initialize any vector array with the size, we just need to use it by specifying it inside the column, inside these brackets, after writing the variable name. Okay, okay, here 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 we are defining the size of this vector, not this. This is just a vector of elements, but here we are initializing this vector, not this. Okay, so if we specify the size, if we specify any size over here, it will be initialized as the size of this vector, this row vector, like how many number of rows will be there in for this vector array. Okay, so and that's how it works. So the size will be the number of rows, and we have this number of rows value as a parameter, so we can initialize it with that. Okay. After that, to do is we just need to so after initialization step is done, we can start with the loop. For every row we need the loop. So uh, for every row we need a loop to insert the elements, and like for first we need to initialize the number of columns value size of that row, and after that we need to initialize the values for each column, for each block, each column. For that reason we first need to start the loop. So I is less than, this is the common format for the loop. We need to run this loop till number of rows, because we are starting this loop from 0. As you know, if we start anything from 0, we need to run it till not till that, till that value minus 1 value. Yeah, so this is the iterator for every row and for each row. And now for each row, what we need to do is we first need to initialize the size of, we like here we have two steps. Either what we can do is we can just use this method called pushback for every row, this pushback for every row without defining the size of the vector array of every row. This method will allocate the memory each time for every value. Like here we don't need to specifically define the number of columns value for each row. Like here without specifying the number of column value, we can just use this pushback every time we insert any value to the column. But here that will be too much complex thing to do. Here we can just like initialize, we can first initialize the columns, like we can allocate the memory. For allocating the memory, we can define the number of columns value for each row, so that the memory will be allocated and we can use it directly as an array only without using that pushback, because that pushback method is seriously a pain to use, but still we need to learn it and use it, because it's used in every problem out there if we don't have specifically defined the size of an array. So for that reason we have to learn it, but for this problem we don't need to use that. We can just define, for each row we can define the number of columns values, so that the memory will be allocated for the vector array inside every row, for every row. Yeah. So what we can do is here we need to use that result, this I. So what this is, this whole thing, this is every row, this is the array of every row. For the row of index I, this is the array of every row of index I. So for 2 index, if we use 2 as an index, this will be what? This will be this array. Okay, this will be this array. Okay, so this is just we can say a vector array for each row. So for each row we have the iterator as I. So for each row we need to first we need to do is we need to allocate the memory for uh, using it as an array so that we can initialize every block of it. So for that reason we have this method called resize inside the vector standard template library. Here what this method do is, let me just explain a bit about it. For this resize, well, this resize, yeah, what this does is this resize is the container so that it contains an element. So what it does is it just uh, initializes the size of an array with n, okay, of the vector array with n, okay. So basically it allocates the memory to the vector array. So for each row, this is the row, for each row we need to resize the number of columns. We need to allocate the number of columns value for uh, making the triangle. Of course, for each row we have this, so for each row we need to specify the number of columns value, and the number of columns value is what? It's I, it's actually I plus 1, because as you can see, this is the I, okay, this is the I. For this I, like suppose we are checking for this I is 2. For each 2, uh, just for each 2 we have to define the, we need to write the number of columns. So for the 2 now, for the 2th index of the row, 0 1 2, here we have 3 elements, so the column number of columns will be 3. For this we need to resize it as 3, okay. So this will initialize the what we can say, the list of the number of columns, the number of columns element for each row, okay, so that we can later on we can initialize the value for every block, okay. Basically we can also, we had also, like in array we need to define, we need to write the both the number of rows and number of column values at the initialization step itself of this of that 2D array. But here we as we have the number of rows as fixed, so we can define that, at the initialization step of the vector array. But for each row we have different number of columns. So for that reason we need to initialize the number of columns value for each row differently. To why we need to initialize the number of columns value inside the for loop, inside the iterator itself. We need to initialize the number of columns value, okay, because for each row there will be different number of columns, okay. So for that reason, so now as you can see, this was the iterator I, and here for each row we have to initialize the number of columns as I plus 1. As you can see, for the rowth, this is the rowth fourth, because it starts from 0 0 1 2 3 4, 0 1 2 3 4. Yeah, so for this fourth index row we have number of columns as 5, so 4 plus 1 is 5. So for each rowth index we need to initialize the number of columns value as I plus 1, okay. So now we have, so now our triangle is prepared. We just need to now initialize every block value, okay. For that reason, so here we can first initialize the outermost values, because these are all ones, so that would make the solution go easy, okay. So for each row we have the first block value as well, and the last block value also as well, okay. For each row, as you can see, for each row we have the first column value as one, and the last column value also as one. So what we can do it is we can first write as I, like it's a basic array only, so we can write it as 1. Okay, and what is the last element? The last element is, for each row the last element is the index of the last element is, for each row it will be different, because for this row the index of this will be 1, for this row the index of this will be 2, for this row the index of this will be 3, for this row the index of the last element will be 4. Okay, 0 1 2 3 4. So it depends on I, the last element index depends on I, the index of the row. Okay, so what is the last element index? It's the 0 1 2 0 1. If we take the ith value of this row will be 4, and the jth means the index of the column is also 4. It means the j is equal to I. For each last element, the index of the column is same as the index of the row. So we can write here I itself. Okay, that also will be 1. Okay, now we have initialized the outermost values for this array. So now what else we're supposed to do? So now we can approach this problem now. So no, only the middle values are remaining, and for the middle values, like as there can be n number of my middle values for every row. Got the point? As the thing which I'm saying is, for each row there can be n number of middle values, but the outermost values will be 2 only. Except for this also, of course. The for like for sixth index, for the sixth row, if the sixth row was there, the number of middle blocks will be more than this, will be 4, and for every nth row there will be n number of there will be m number of middle elements. So for that reason we need to initialize the middle elements through a loop. That's why we need to run a different loop for initializing the middle elements. We can use a different iterator this time. J will start from not from 0, because here we have initialized the 0, the first element of the vector already. We have uh, initialized the first and the last element of every vector array of each row. So we need to start it from 1, and we need to end it where? We need to end it uh, at I minus 1. Okay, here we need to use I minus 1 because we have initialized the last element as well, and for each row there will be like the number of middle elements depends upon the ith index, the rowth index, because it will be different only. So for every loop, the loop for every middle elements, it will be variable, not fixed. So we need to use I over here. It's dependent the j. It depends on the rowth index, so that's why we need to use this j plus 1. Okay, yeah. So this is the loop that will run for the middle elements. Starts from this and ends to this. Okay. So now we need to use that formula that we derived before. For each element, it will be the value will be the addition of the previous rowth column index minus 1 element plus the rowth the column index has the same these two values. Basically for this value, this value is the addition of both these. So for by using that formula, I can show you that. Yeah, so this is the formula. Here we need to use this directly for every element. It's the row width minus 1, because both the elements are row width minus 1, the previous row elements, and the first element will be the column minus 1 just before the column minus 1 index, and the other element is the same as the column index, will have the same column index. Okay, as you can see, for this element the value will be the addition of both these values. Okay, so that's how it works. So writing the formula now, result of I of j, the value that we need to calculate is, as this is a loop, and of course the previous row values are already calculated and assigned, so we can use the previous row values without thinking of it. So the value will be the the ith index will be -1, as we know, and the first element will have the column index as -1, and the second will be having the column index as j itself, the same as this. As you can see, for this three element, the j is 1, and for this element the second element was 2, and for that 2 also the jth index was the same as this. So 1 and 1 both have the jth index as 1, and here the jth index is 0. So that's 1 minus 1, that's 0. So this is the formula. Now now after that it returns the result. Now the problem is completed. Let us just run it. Long answer. How are you? It's calculating 0. Should return 2. Okay. This loop is somewhere. The middle elements are not getting correctly assigned. Okay, sorry. Here we need to use I, because the thing is, this I is already the number of columns value -1, because let's just see, the I start from 0 and still here. Okay, so it's already as number of columns -1. Here we usually write the number of columns value, and here we have specified the last element, so we don't need to run it for the last element. So that's why we have to write number of columns -1, but this I itself is number of columns -1, so we don't need to write -1 again with this I. Okay, so now we try to run it. Okay, it's accepted. Correct. Yeah, it's faster than 100%, so it's the most optimal solution. Here we can't use DP and other memorization techniques, because here we have nothing for memorizing. As you can see, every element is different from the previous element. For every element we need to calculate the value. We can't just escape from it, so we can't just use dynamic programming or memorization over here. I will share the code too. Okay, don't need to worry about it. Yeah, so this was the easy problem, not so difficult, but still, yeah. So for here what we can also do is, if you don't want to specify both the first and the last value outside the loop, what we can do is we can remove it from here, and we can inside the loop itself. For this we need to start the loop from 0, and for the last element we need to use +1 as well. So here what we can do is we can have some if condition. If for the uh, j if j equal to 0 or j equal to I plus 1, then only assign the resultant value as matlab means if the column is the first or the column is the last, then only assign the blocks value as 1. So yeah, else the same only the same formula will be used for the middle values. Okay, yeah, so now it's done. Now it should work the same. What we have done is, so here we wrote we initialize the first and the last value outside the loop. Now we are just initializing the first and the last value inside the loop only, by specifying one condition, that if the column is the first or the column is the last, then only assign the value as 1, or else use that formula itself. So run this code, it will work the same way. Runtime error buffer over. Okay, might need to. Okay, so here it's the same only. Here we just need to use, because it will run till I, j will run till I, not I plus 1, because it's less than, so that's where j will run till I. So if j equal to I means the last element, or else j equal to 0 means the first element. Yeah, so now it's working fine. This also you can use. Yeah, it's also the fastest. Yeah. So this is also one of the solution. I just wrote this condition the same only. Yeah, so let us just end over here. Thank you so much guys for watching this. I hope you enjoyed. We will be solving more problems afterwards, more complex than this. This was very easy problem, but we don't get these type of problems in any bridge program, Infosys bridge program contest, or other competitive programming platform. So we have to practice much harder. Yeah. So thank you so much guys. Let us just close it. Bye everyone.